Can't really see it. It's 0.9987. So actually the area here under the curve is 0.9. Did I say 99? It's 0.9987. Okay, 0.9987, which means that the area from here across must be 1 minus it. So the area from here across is 0.0013. Okay, 13 is the area over here. Okay, that's 1 minus 0.9987 gives us a value of 0.0013. Now don't forget, 3 standard units on this side, okay, is going to be, it's minus 3.00, okay, is over here. So that means that the area in this tail here must be the same as the area in that tail over there, which is 0.0013, which gives us that the area in between these two, okay, is this long line minus the shorter line. It's going to be 0.9987 minus 0.0013. And you can see what that gives us there, yeah? So that's 0.9987 minus 0.0013 gives us a value of approximately, well, to 4 decimal places, it's 0.9974. Okay. Now I've said that within 3 standard deviations you'd expect to find 99% of the observations. But actually what you'd expect to find is 99.74% of observations should be within 3 standard deviations. Okay. So let's just update our table here, okay, or update what we had earlier on. Okay, to be more precise, this should be 68.28%. This should be 95.44%, and finally this should be 99.74%. Okay, so what am I saying? I'm saying that if your distribution is normally distributed, okay, irrespective of its mean and standard deviation, if it's normally distributed, that means under the transformation we can get back to the mean of 0 and standard deviation of 1. What we'd expect to find is that if you take the mean value of your distribution and if you add on a standard deviation and if you subtract a standard deviation, that these 2 points, these demarcation points, maybe I'll just draw that on a curve in a little bit more detail, okay, that these demarcation points, okay, these lower bounds and these upper bounds, we'd expect to find a certain percentage of the observations. Let me draw a little curve that's a little bit bigger. Okay, what I'm saying is this, is that if we have a standard normal distribution that looks something like this, okay, there you go, hopefully that sort of works out for us, okay, it's centered on a particular mean value, okay, it's on some mean value x bar, so our distribution, our sample has a mean value and it also has a standard deviation s. And what we're saying here is this, is that if we take one standard deviation on either side of it, if I come out one standard deviation here, one S and one S on either side, okay, that I'd expect to find 68.28% of the observations. So 68.28% of the observations should be within there. Okay, really what we're saying here is this, is that within this particular interval here, let me do this as big lines, okay, within this interval here, okay, that we should have 68.28% of the area under the curve, okay, or 68.28% of our observations. Okay, if I come out 2 standard deviations on either side, okay, out to here, 2s and 2s on either side of the mean. In other words, I take a standard deviation, 2 standard deviations away from the mean, I add 2 standard deviations onto the mean. Well, what I'd expect to find is 95.44% of my observations. In other words, within 2 standard deviations of the mean, okay, we should have 95.4% of all of the area under the curve, if that makes sense. Okay, so the area all under the curve here, okay, should be 95.44%, okay, of our observations should be within those particular bounds. Okay, and then finally we have, and you can sort of see what's happening here, is that within 3 standard deviations of the mean, within 3 standard deviations, here's our mean, 3 standard deviations, 3 standard deviations below, 3 standard deviations above, we'd expect to find 99 99.74%. Okay, actually, what this is really saying to us is this. If I go back up to the curve here, okay, so within this, that's 3 standard deviations, okay. Okay, what this is really saying is this, is that observations that are more than 3 standard deviations away from the mean, either above it or below it, yeah, that these observations, yeah, are very rare. Okay, they're very rare. We shouldn't really see them that often. Okay, they're very rare, because we should have nearly 100% of the observations within 3 standard deviations. Okay, guys, once again, this was Jonathan Lambert with the Mathematics Development and Support Service at the National College of Ireland, and this short video dealing with the empirical rule. And more importantly, we sort of done its derivation, yeah, okay? We've identified what these percentages should be within 1, 2 and 3 standard deviations of the mean, okay? I hope that this video was in some way intuitive, and more importantly, I actually hope that was helpful for you, and thank you for watching. Okay, bye-bye.